We need to find the number of non-differentiable points of y equal to mod of log of mod x to the base e. Now this problem is more convenient to identify the points of non-differentiability. One method is express this function mod of log of mod x to the base e as piecewise defined function. Check the breaking points and identify the differentiability on the left side and right side of each of the breakpoint. But it would be more convenient for us to draw the graph of this function and identify the points of non-differentiability of the function. Yes, because it is more convenient to draw the graph of log x. When we consider the coordinate axis, how will be the graph of log of mod x to the base e? Yes, when the outer modulus will change its sign, if the inner value is positive or negative, that possible at 1 and at -1. Now between 0 and 1, how will be the behavior of this logarithm function? At 0 it becomes infinity, and by the time we reach 1, the logarithm value will become 0. Now similarly, as x moves from 0 to -1, then also as because of mod x, this will be a image of this with respect to y-axis. That means the graph on from 0 to 1 would be again starting at infinity, and by the time we reach -1 it becomes 0. Now again let's come to the first quadrant. From 1 to infinity, log x is an increasing function, right? And it goes down to the negative values, but because of mod of log x, this would be now going up, right? And as the outer modulus is there with the inner modulus mod x, the graph of the function from -1 to -infinity would be image of this portion on this side of y-axis. That means this would be the graph of. Now if you look at the total graph here, we have two very important observations to make. The first observation is at x equal to 0, the function f of x is discontinuous, right? Now, every discontinuous function at the point of discontinuity is non-differentiable. Therefore, shall we conclude f of x is non-differentiable at x equal to 0. We have identified one point of non-differentiability. Not only that, if you observe the graph, there is one more important observation. At x equal to +1 and -1, f of x graph has sharp edge in it. Now a function which has a sharp edge at a point, clearly at that point, f of x is non-differentiable at the 2 points x equal to +1 and -1. So we observe two more points of non-differentiability. Now what are the total number of non-differentiable points? One at x equal to 0 and one at 1 and the next one at -1. There are total 3 points where the given function is non-differentiable, right? Now as an observation we can also say at x equal to 0, the function y equal to f of x has vertical tangent. That means y-axis becomes the tangent at the point. So therefore the value of f dash 0 would tend to infinity. Not only this, at 1 and at -1 if you observe, f dash at 1 plus will not be equal to f dash at 1 minus, and similarly f dash at -1 plus will not be equal to f dash at -1 minus. The left hand derivative and right hand derivative at -1 and the left hand derivative and right hand derivative at +1 both will exist, but they will not be equal. Okay.